As you can see, the title of this presentation is about convergent and discriminant validity and common method bias. These are essentially dealing with how to counteract any sort of unwanted effects in your data to actually see the effects for what they are. And here's a brief outline. First, I want to talk about information processing, which pertains to the way that people make decisions about how to respond to different types of questions on different types of instruments. So we'll look at that. And I'm using this acronym IP, which stands for information processing, so you'll see that pop up throughout the talk. Next up, I want to talk about choosing appropriate measures and how to go about making sure that the measures you're using are in fact valid to use as measures of the constructs that you're interested in and not others that you may want to avoid. And then choosing appropriate methods for actual data collection. This will definitely tie back into information processing because of the way that you present information will impact the way that people think about it. And then, in turn, that influences how they respond. After that, we'll look a little bit at methods to prevent bias in terms of data collection and statistical techniques to account for bias if it actually is evident in your data. There are some techniques that you can use to try to eliminate it. So let's start off with this image. Perception is reality. So some people look at this image and they see one thing, other people look at it and see another. So for some of you, you might be seeing a young woman looking away from us, from the viewer, and you can see sort of her chin here and her nose and an eyelash and her ear and her jawline, her neck, and she's wearing a necklace. Other people, when they see this, they say, I don't see that at all. I see an old woman, and here's her left eye, this is her nose, right, and here's her mouth. Depending on the sort of internal processing that you bring to the situation, you're going to see a different version of this image than somebody who brings a different perspective from their own experience, from their own bias, basically. And I'm using this just as an illustration of the stages of information processing that are pertinent to self-report. There are a number of stages through which we basically build up these perceptions. The first is comprehension, then there's retrieval, judgment, response selection, and finally response execution. And I'm going to talk about each of these in turn very quickly to sort of demonstrate what can, what kinds of information processing are implicated in a process that may appear as simple as just checking a mark in a survey item. So first of all, comprehension and retrieval, these are closely related. What happens is, first you have to attend to the instructions that are given, right? You have to then interpret those instructions, what they mean to you. You have to identify the information that you perceive as being sought by those instructions. And that might already mean different things to different people. Then you have to link the question text to those personal meanings, to the relevant concepts that you perceive, to the memories from your life that you have, and then fill in all of the details that are missing from your sort of concept of those instructions according to, you know, your own personal meanings, your own relevant ideas and memories that you bring to the table. So this all will dictate how you understand a set of instructions or a set of questions, or individual questions rather. Then you have this next stage called judgment. Judgment has to do with drawing inferences about the information that you've retrieved. So first of all, you've taken the information from the instructions, from the item, and now you have to come to an understanding in your own mind of what it means and what it means to you. So essentially what you have is a sort of internal concept of what a certain piece of information means. And then you have to kind of, fill in those gaps. And here at this stage, what you're doing is building an opinion based on that concept, based on the inferences that you've already had to make on, the input that's coming in. Next up, once you have built that judgment about, whether you agree with something, disagree with something, how strongly it affects you, etc., you have to make a decision about what response you're actually going to make, right? So any survey instrument, any question that you ask a respondent has some answer options, and these are going to be limited in terms of what they allow the participant to respond with. So there's a sort of potential disconnect between what a person thinks and then the options that they're given, and they have to reconcile those two. And so there's going to be some ambiguity there as well. And then finally, once you actually have selected a response that you think is genuine in your own mind, there's this actual fact of having to put a response down on paper, or make a response to an interviewer, or make a response on an electronic survey, right? So this is where even if you believe one thing, you can say something else. So there's a number of potential influences on this, but basically there are a few major ones that we're going to see pop up throughout the presentation, so I want to make sure I note them now. There's this idea of consistency, social acceptability, and then sort of others. But consistency is where you want to appear that you have a sort of consistent set of ideals by which you are responding. And the other piece of social acceptability is you don't want to answer in a way that might be perceived as being, either weird, or might get you in trouble, or might make you seem immoral, anything that would be outside of the sort of social norms. And then, finally, there's this last step of physically making a response, but, that's relatively minor. This is just background from cognitive psychology. Anyway, the takeaway here is that information processing can influence responding at any one of these points along the way. So when it comes to that first stage, you've got ambiguous instructions and or questions that are open to interpretation, and here certainly social desirability can play a role as an example. In terms of judgment, you have things that are called priming and anchoring effects, and some examples of this are consistency motif and demand characteristics. What this means is, again, coming back to this idea of consistency, how does the current item that you're responding to fit with your previous response? You have to think back, okay, I remember how I answered a related question before, so now since I am a consistent person, I have to answer it in a manner that's consistent with that previous item, right? And demand characteristics are related to this in terms of not what your internal consistency is, but what you think the external demands on you are. So it's kind of a really well-studied phenomenon where people try to predict what a survey is getting at. What is it that is being sought of me as a participant, and then I'm going to answer accordingly. Response selection also has to do with anchoring effects, and so again, anchoring effects have to do with consistency, demand characteristics. What they also have to do with is looking at previous items. If an item is phrased in terms of, do you strongly disagree or strongly agree with, this item, then the next item is going to be evaluated in light of that previous item's anchors. Anchors being the first response option and the last response option. Those things tend to carry over into the next item and so on and so forth, all the way through the entire survey that you might be administering. So let me just give a quick example of that. If you have one question and the item is, your cat died. Imagine that your cat died. do you strongly agree that you feel bad? That's going to put you in a mindset. If the next question is ice cream tastes good, and then do you strongly agree with that, now you've kind of flipped everything on its head, because the strongly agree piece is still anchoring the person's responding. So even though the previous question was about a cat dying, which is, you know, a horrible thing. I love my cat, and if it died, I would feel terrible, and I would really strongly agree with that statement. And then you throw another question at me about ice cream tasting good, and I have to strongly agree with this. Well, now I've got a bit of discord, because I'm still anchored in that strongly agree response from a completely different question. So this is going to affect my responding on subsequent items. And then finally, we've got the response reporting stage. All of these previous types of information processing influences can be affected here, but particularly social desirability, because now it's the moment of truth, right? Whatever you might think, you have to actually, you know, make a response that's going to be visible in some way. And when we're talking about items that have to do with professional implications, for example, doing surveys at people's places of business and how they feel about work, there's another item called negative affectivity that's related to social desirability that we'll look at a little bit later as well, actually. I don't want to go into too much of that right now because it's covered later on. Okay, so moving beyond what happens within a scale, we also have issues with what happens across scales that use the same types of methods. So essentially, this is called common method bias. If you have the same technique used for a predictor and an outcome variable, for example, if you're looking at, let's say, job satisfaction and job performance, and you're using a measure with all, you know, Likert type items, then you use the same type of instrument to measure the other variable of job performance. Then you have a potential for common method bias to emerge. You are typically going to be using the same participants to collect data on both measures, and you're probably going to be collecting data at the same time on both measures and collecting data in the same place. They're going to be sitting at, you know, a computer or at a desk or what have you, across an interview table, whatever the case may be. What's important to note is that if you're using these sort of common methods, they can actually account for up to 40 to 80% of a correlation. So it's not necessarily the case that you found a correlation between two variables. It's that you've actually gotten people to get into a mode of responding where they're just kind of agreeing or strongly agreeing with all the items regardless of what's being asked. And that kind of phenomenon can account for a lot of an apparent correlation that may be misleading, because you're thinking, oh, I found a significant correlation. Well, what you may have found is a common method bias. And that's what's explaining the correlation, as opposed to an actual genuine relationship between the variables. And by the way, I cite a number of studies in this presentation. There's a list of references at the end, so you'll have access to that as well if you want to do more background reading on this. Let's do a quick illustration of common method bias. Let's say that your IV and DV stand for independent variable and dependent variable, same thing as predictor and outcome, or predictor and criterion variables. Let's say they both use 20 Likert type items ranging from, you know, strongly disagree, disagree, neutral, agree, strongly agree, right? So you have 40 items total. Then an invitation to participate was sent to a bunch of participants' work emails through some professional listserv, for example, or, you know, through their organization directly. And then finally they're administered, you know, one after the other via SurveyMonkey, very popular survey research website. What can happen is, if they're both using the same types of items, then, you know, as I mentioned on the previous slide, you might have response set formation where people are just saying, oh, you know, I strongly agree with the last one, so I'm going to strongly agree with this one. Regardless of what the actual content is, people just begin to start responding in a similar fashion to questions over and over again. And then, again, this ties in with the consistency motif, right? If I believe in X, I probably also must report that I believe in Y. The invitation sent to work email piece, this sends contextual clues, right? The environment in which you're answering these questions has implications for how you're going to respond as well. If you think that this has something to do with your work, then you might be more likely to succumb to these kinds of social desirability effects of wanting to respond in a way that's going to make you look good, right? Because who knows who's reading these results, right? What is it being used for, so on and so forth. Finally, if they're administered one after the other, then again you have this consistency motif and social desirability coming into play for a lot of the same reasons. And we'll also see later that there are things called order effects, where if you administer one survey after the other consistently in the same order, the one that comes first is going to influence how people respond on the second one. And again, this ties back in with the consistency motif, as you see here. Okay, before I talk about instruments, let me pause for a second and see if there are any questions. If not, I'll just continue. It looks like we're good to go. Alrighty. So the instruments that you choose are just as important as the methods you use to administer the instruments. There are two main things to keep in mind when you're selecting instruments for your study. The first is convergent validity, the second is discriminant validity, and it's very important to take into account whether both conditions are met. And I'll give an illustration of why this third piece is important, but first let's look at them individually. So convergent validity is the degree to which an instrument actually measures the concept or construct it is intended to measure. And this is evaluated using different techniques. So things you're looking for when evaluating the convergent validity of an instrument is Cronbach's alpha, whether a factor analysis was conducted, and sometimes you'll see that meta-analyses have been conducted to establish convergent validity of an instrument. Very briefly, Cronbach's alpha is the consistency of items within a scale. A factor analysis, and we'll look at factor analysis later in this presentation, it's a technique that lets you know whether or not all the items on a scale actually tap the same construct, which is synonymous with factor in this case. And if that's what it was designed to do, that's great. If the survey was designed to tap into two separate constructs, then a factor analysis will tell you whether certain items load onto one factor and others load onto another, and that's what you're looking for, right? If it's designed with two factors in mind, the items should be loading on two factors. If it's designed with one factor in mind, they should be loading onto one factor. If this is not the case, then you have to really beware. And discriminant validity, on the other hand, is the degree to which an instrument does not measure other constructs. So you want your instrument to be measuring one thing and one thing only. So in fact, the logic here is that there should be a lack of correlation with theoretically unrelated instruments. And this is the way that surveys, questionnaires, inventories, etc., all kinds of instruments are designed, is that you administer things that are unrelated and hope that you do have discriminant validity of the measure that you are developing. I see that there's a question. I was wondering how the common method bias might influence a participant's responses if they respond to an online survey in isolation from other organizational members. That is a very good question, and I think that it is going to be less of an influence, but it still might be there. And I will discuss some techniques for minimizing the bias regardless of whether it's filled out in private or with knowledge that other people are also filling it out. Overall, I will say that it is often difficult to provide information about what other people are doing to a participant, but you can certainly include instructions that put people's fears to rest, so to speak. So hopefully that clarifies things a little bit for you, Dante. If not, feel free to follow up. All right. So with these issues of convergent and discriminant validity in place, let's look at a quick illustration. Before I do that, though, just a side note, if you are looking to use an instrument and they don't report the convergent and discriminant validity of the instrument, steer clear of it. Okay, well, unless you're developing an instrument as your dissertation, in which case that's a whole different can of worms. But okay, so let's look at an illustration using instrument X. Conversion validity. So items on this instrument are all written to, quote unquote, tap into, let's just say, job satisfaction, right? It's a measure of job satisfaction. And a factor analysis is conducted, reveals a single factor structure. This is good evidence that all the items do actually target one construct. And since all the items are written with job satisfaction in mind, logically we can conclude that this instrument actually does tap job satisfaction and not, separate aspects of different types of things that people are interpreting. If that were the case, then you would see that there would be a multiple factor structure. But let's say that instrument X is also strongly positively correlated with a measure of home life satisfaction. Well, you know what? That actually means that instrument X is actually not all that special because it doesn't discriminate between domains of satisfaction, right? If it weren't correlated with home life satisfaction, that would tell you that it is more specifically related to job satisfaction and not just satisfaction writ large. You could use many different types of instruments to establish discriminant validity. I'm just using one here that is relatively closely related to illustrate the point that depending on how specific your intentions are, there are going to be different sort of criteria by which you're going to need to establish good discriminant validity. And you see that there's this note here about a marker variable. What that means is that the reason I'm highlighting it is that we'll come back to marker variables later in the presentation. So it's important to note that in your own work, even if you're not developing an instrument, you can still use marker variables to establish whether or not common method bias has intruded into your research. Okay, so all these problems, what are we going to do about them? Well, first off, as I mentioned, you want to choose validated instruments. Second of all, you want to make sound methodological decisions, and then you can evaluate your data statistically. So for the rest of the presentation, I want to focus on these second 2 points. We are going to look at data collection strategies that will help you avoid bias. We're going to look at statistical analyses for diagnosing whether bias exists, and then finally looking at some statistical analysis strategies for treating bias if it exists. So hopefully it won't exist because you will use data collection strategies that will avoid it in the first place. That's sort of the first line of defense here. So I'm going to be using these kinds of medical metaphors, diagnosis, treatment, prevention, throughout the rest of the talk. Okay, so using multiple data sources, this is one of the first methodological preventative measures. It's similar to triangulation in mixed methods. Triangulation is where you use different sources of data to zero in on the construct that you're interested in. So you might have a survey, you might conduct interviews, you might get information from people who are also able to provide information about a certain individual. And there are a couple of examples here, so let me go through those. You can first of all obtain data on one instrument from a different sample than the second instrument. However, this is not often possible, and it exposes participants to potential anonymity concerns. So let's say that you are, again, doing a measure of job satisfaction and job performance. So you could certainly have job satisfaction come from the employees. Or if that's your target group, you can be looking at employees, you can be looking at managers, you can be looking at whoever. But you get that information from them. And then if the other variable is job performance, certainly it might not be such a good idea to ask them how good they are at their jobs because, again, social desirability, right? But if you have access to their managers, then you can get data from them about the performance variable. Now, again, if that's what you're doing, then you have to be careful about anonymity, because if somebody is providing information about one employee, then that kind of might alert them that that employee somehow needs to be looked at closer for some reason, independent of the research that's being conducted. However, if a manager is being asked to provide job performance information about all employees, then that is much less of a concern. However, there are going to be very specific issues regarding anonymity, and we'll look at that a little bit later. But it's important to note that even though there are benefits to obtaining data from a separate sample about the same participants, it does raise some ethical quandaries. And you can also get information from multiple sources, not just other individuals, like I have in this first example about job satisfaction from employers, job performance from employers, but you can also get information from things like intake notes, therapist assessments. Depending on the field you're in, there are going to be different options. If you're in an educational setting, you can get information on grades, on attendance. You can be very creative, and as long as you're maintaining ethical standards of anonymity and confidentiality, you can use multiple data sources. So basically the idea, going back to this medical metaphor, is obtain a second opinion, right? So that's one technique. Another technique is to collect data in different contexts and at different times. The idea here is, going back to the cognitive psychology of it all, that these demand characteristics that people perceive, the consistency motifs that they develop, the social desirability that they perceive themselves as needing to exude, are all literally forgotten over time. So the idea is that you can separate different measures in time, in space, and in terms of the person's psychology. So the idea is that, the short-term memory fades, and it's like, okay, what was I trying to be consistent with again? Okay, I forgot. So now I'm going to be answering in a way that is more truthful now, as opposed to trying to be consistent with my previous responses. I don't even remember what I'm trying to be consistent with. The spatial separation piece, you can literally have people fill out a second instrument when they get home. The idea is that if you separate the context from the measure, you can often remove people's biases, because if they fill out measures at home versus at work, that can have implications independent of whether they're thinking they're being surveilled while they're filling things out, etc. The idea of taking a break, you can include this in your instructions. There are lots of these different kinds of ideas that you can implement to help people forget their biases. There is also another technique of using different collection techniques for different variables, where you can literally give an online survey of one variable, but a paper and pencil version of another. Obviously, this is going to depend on your resources, so that's why I'm using a lot of different options here, because it's not always possible to do things. The real world gets in the way sometimes, right? Another technique, use a cover story. Basically, explicitly indicate that one survey that's coming up next is not connected to the previous one that they just took. And this is the piece of psychological separation up here, where you can prevent people from assuming that the two are related, and thereby assuming that they have to have these consistency motifs and desirability characteristics. If you literally say that they're not related, people are often put at ease. Now, there are a couple of cons that I want to make sure I emphasize because of the ethical aspect, which is to say that you might need linking variables. If somebody is filling out one survey online and another with a paper and pencil, how do you put them together, right? You have to have a unique identifier, which might require you to collect identifying information. One way around this is to ask for a unique type of ID, not their social security number, not their birthday, not their phone number, not their first and last name, but have something that asks for maybe a middle initial and the middle 3 digits of their phone number. Something that is still unique to them, but is not immediately identifiable if somebody were to get their hands on this information and have some kind of malicious intent. Not that that would ever happen, but you have to make sure that you preserve anonymity. Okay, I started talking about this on the previous slide using a cover story, but the instructions themselves are also a good way to prevent common method bias, where you indicate that there are no right or wrong answers, you indicate that people should answer as honestly as possible, and also just remind them that these are all anonymous and confidential responses they're making. So this will prevent common method bias as well as some of these information processing biases that we've been looking at. And finally, can't stress this one enough, assure anonymity. The problem, of course, is that people fear that there will be some kind of repercussions, that they're going to be misperceived, ostracized, even fired due to identifiable data becoming publicly available. And if that happens, you want to make sure to have good anonymity procedures in place, like I've sort of talked about, and also include those statements explicitly both on the consent form and, again, reminders in the instructions before each instrument that you administer that it is, in fact, anonymous. And finally, don't even collect identifying information if it's not needed. If your research questions do not require you to know the gender, the race, the age, and you're worried about anonymity, don't collect the data. There are definitely benefits to having demographic information in your results section, but if that information comes at the cost of not being able to collect valid data, it might not be worth it. There are some criteria about whether or not you need to have identifying information on the consent documents at the Health and Human Services website that the federal government publishes, and this is what the IRB also follows. And if you go to this website, if you're actually going to be watching this on YouTube, you can see the link there and you can click on it. So that is there for you. And those criteria will help you understand whether or not you actually need to collect that identifying information and have it be written down, or rather recorded. Okay. Another solution to common method bias is counterbalancing, and counterbalancing is a technique that addresses the problem of order effects. So as I mentioned previously, if you always do the instruments in the same order, you're going to have the first instrument influence how people respond on the second one. So the solution to this is that you switch the order. So for the first person who comes in, they do instrument A first, instrument B second. The second person that comes in does instrument B first, instrument A second. And there is an alternative to SurveyMonkey, which is this psychsurveys.org website, where it allows you to very easily counterbalance the order of the instruments that you have in your study. Whether it's 2 of them, 3 of them, it can be any number that you want. And actually, let me just go to this website here and show you what it looks like. If you go to psych surveys, you can see that there's a help section up here. And first of all, you're going to want to set up an account. It's all free, everything like that. And under help, oh gosh, I forget where it is. Let me just search for it. Counterbalance. There it is. Counterbalance or randomize the order of survey pages. And you see that they have instructions for how to actually go about doing that. So highly recommend this as a survey tool. Now, it's important to also note that you don't counterbalance the order of items within each instrument. That is the idea behind a lot of these instruments that have been validated, is that they have a certain order of questions. So you don't want to mess with that, because then, again, you're going to be setting up a situation in which the priming of previous items is different for subsequent items than the scale that has been validated. So you want to make sure that you're not changing the order of items within your instruments, but only across instruments. Okay, now back to the medical term, diagnosis. The question is method bias an issue in your data? And if it is, factor analysis is going to help you understand whether it is. Exploratory factor analysis in particular. And this is distinct from confirmatory factor analysis, so I just want to make sure that we're clear. Exploratory factor analysis is where you are basically looking for the number of factors that exist in your data. You don't force a one-factor solution or a two-factor solution, which is what confirmatory factor analysis does, where you actually look for a certain factor structure. So here, what you're looking for is whether you put all your instruments into a factor analysis and you look at whether all the items from instrument 1 and instrument 2 all load onto the same factor. If they do, it's a clue that it's a pretty strong clue that people have been responding the same way to all the items on both instruments, regardless of the content. So if you've used validated instruments, you should certainly see at the very least that instrument 1 loads onto one factor and instrument 2 loads onto a second factor. And technically this is principal components analysis, but you can call it exploratory factor analysis. They're often used interchangeably in the literature. Okay, so in terms of factor analysis, you might be starting to pull your hair out thinking, how am I even going to test that? Well, there are a couple of really good resources that are very accessible, and again, there are some links here that you can use to conduct a full factor analysis, taking all assumptions of the analysis into account. All the SPSS output that you would need is covered in these resources, so feel free to use those. They're freely accessible online. And that will go a long way to helping you understand whether or not you have some issues with common method bias. Another diagnostic tool is looking at reverse-coded items. And these are basically items that are phrased in a sort of reverse manner from other items. And these are embedded in many existing instruments. What they're designed to do is to force respondents into thinking about responses. So if early on in the questionnaire, it says, do you like ice cream? Yes or no. Then later on, you might have a question about, do you dislike frozen treats? And then, the person should be thinking about, okay, it's not that I like anymore, it's that I dislike. So oftentimes these are included, and then, you have a sort of reliable way to check for common method bias. And, I'm sorry, not common method bias, but information processing bias. And if these don't exist in the instruments, you can add your own at the very end. And I emphasize at the end because if you put them at the end, then they cannot influence responses on previous items, right? You're still using validated measures, and then at the very end, if there are no reverse-coded items, you can add your own. And so how does the diagnosis work? You may have a problem if either participants agree with an item and its reverse-coded counterpart, or if participants agree with an item and conceptually opposite counterparts. So oftentimes what you'll also have in an existing instrument is items that are designed to tap into something that is opposite of another construct, and then you can look at those and compare them as well. So again, you can look at response set formation. If people are responding in ways that are contradictory, then you can start to think about what to do next. Oftentimes the solution is to remove participants from analysis because their data are not trustworthy. Oftentimes if people are answering using a response set, you'll see that 75% of their questions are all strongly agree. Those are clues that those data are not worth using. Okay, next up we've got marker variables. I mentioned these earlier. This is a technique that's used where you have a variable that has been established as being completely unrelated to the measures of interest that you're actually looking to analyze. So it should thereby be not correlated significantly with your measures. And then if you include it in your set of instruments that you administer, then you should probably find no correlation. If you do find a correlation, it's likely that a common method bias has intruded, because why should they be answering in a way consistent when we know from tons of literature that these are unrelated constructs? So that would be a pretty big clue. So let's move on to treatment. Partial correlations are a technique that allow you to account for different kinds of bias in your data, mostly dealing with information processing bias. And in fact, I would say 95% of the time that's what you can use to use partial correlations to account for. Common method bias really is accounted for in the data collection phase. So what we're looking for is typically we look for zero order correlations. That's where you say, okay, measure A and measure B are correlated at, R equals 0.8, P is less than 0.05, great. Partial correlations take into account different types of information processing biases. In fact, this is very important because up to 40 to 80% of a correlation has been previously shown to be due to social desirability or negative affectivity. So we'll look at these, and the idea is that you don't want to be reporting zero order correlations. You want to take into account how much social desirability somebody is likely to have, how much negative affectivity someone has when responding, and the impact that has, and partial that out. That's why it's called partial correlation, because you partial out or control the influence of a third variable. And again, how do you do this? Well, here are some really good resources. There's a walkthrough in SPSS. I've also done another talk where I do a conceptual walkthrough and an SPSS walkthrough using regression. And regression actually gives you the same information as a partial correlation analysis, which is outlined in this first resource. You can get the same exact information from a regression analysis, but also have more in-depth information as well. So you can partial out as many variables as you want, but I want to focus on two specifically. Social desirability is one, and there are a couple of different versions that you can use. First is the original 33-item scale developed by Crown and Marlowe. And it's taken from the multiphasic Minnesota personality inventory. I don't know if it's multiphasic Minnesota or Minnesota multiphasic. I don't remember at this point. Anyway, those are all sort of been shown to be unrelated. The 10-item version from 1972 has really good internal consistency and the highest correlation with the original scale of a bunch of others that were also analyzed since the original scale came out. You can apply this to any study that involves self-report and account for social desirability to control its influence. And by the way, all these articles are available on Psych articles, which we have access to, and Google Scholar as well. Finally, we have negative affectivity. This is applicable to studies of stress, anxiety, anywhere we have sort of negative emotions coming into play, negative perceptions. And this is based on a 50-item scale. So this is a little bit longer, but depending on how specific your study is to these kinds of constructs, you would want to include it and control for its influence, partialize its influence. So to summarize, even if each chosen measure has good convergent and discriminant validity, information processing biases can prevent arriving at valid conclusions if they're not administered rigorously, right? So in your own research, you have to make sure to prevent common method bias using these techniques that I've described. Check your data for common method bias and statistically control any information processing bias that might be evident. Here is a full list of the references that I've cited in this presentation. Again, this will be available on YouTube, so you can see them there, or you can actually email me at this email address and get a copy of these slides, or just the references, whatever the case may be. I'm happy to share that information with you. And of course, you can always contact us at this email address to request a methodology consultation. So feel free to take advantage of all of those. And